Working with data. Part 2. Quantitative data. Looking at relationships, differences, and change. Before we begin, let's review some key concepts that we've already discussed regarding working with data. Variables are factors that can vary from one person to another. Examples include GPA and social anxiety. Frequency is the number of people with a specific status on the measure or item of interest. Examples include the number of students with a GPA of 3.5 or above, and the number of children with a diagnosis of social anxiety disorder. The mean is the average of participant scores on a measure. Examples include average GPA for a class or average social anxiety score for a group. So far, we have just been describing data for a group. Our next step is to interpret data, to make sense of the results so that we can say something meaningful about our findings. Each type of research question has a specific data analysis procedure that goes with it. There are three main questions. Is there a relationship between two variables? This involves a correlational design, looking at the relationship or correlation between the variables. Is there a difference between groups? This involves a two-group comparison design, sometimes called a causal comparative design. Is there a change over time in a variable? This involves a one-group pre-test, post-test design. Note that the answers to these questions depend on the standards we have set for determining whether a finding is meaningful. We will talk about how to set standards and evaluate the findings later in this mini-lecture. The most basic quantitative research design is a correlational design, which is meant to answer the question, is there a relationship between these two variables? The variables must be measured with numeric data, meaning a measure that yields a score or other number. Some examples include looking at the relationship between self-efficacy and test score, the number of counseling sessions attended and depression symptoms, and physical fitness and reading enjoyment. In each case, we want to know whether the variables are positively related, meaning that high scores on the first measure are related to high scores on the second measure, whereas low scores on the first measure are related to low scores on the second measure, or whether they are negatively related, meaning that high scores on the first measure are related to low scores on the second measure, and vice versa. Alternatively, it is possible that the two variables are not related at all, such that scores on the first measure have no connection with scores on the second measure. To determine whether a correlation between two variables exists, we must follow several steps. Step 1. Obtain numeric scores for participants on two measures. Step 2. Calculate a correlation using an online calculator or spreadsheet, such as Excel. Step 3. Examine the direction of the correlation, positive or negative. Step 4. Examine the size of the correlation. Step 5. Determine whether the correlation is large enough to be meaningful. This will depend on the context, participants, and measures used. Here is an example of a positive correlation. On the y-axis, the vertical line on the left side is the student's test score. On the x-axis, horizontal line at the bottom, is the student's perceived self-efficacy, that is, the sense that he or she is capable of succeeding in that subject. As expected, the higher one's self-efficacy, the higher the test score is. This is represented by the upward slope, also called a regression line. Here is an example of a negative correlation. On the y-axis is the number of depression symptoms a person reports. On the x-axis is the number of counseling sessions the person attended. Also, as expected, a larger number of counseling sessions was associated with fewer depression symptoms. Here, the regression line slopes downward. Here is an example of two variables that probably have no correlation. The y-axis represents the person's physical fitness score, and the x-axis represents the degree to which a person enjoys reading, measured with a reading enjoyment scale. As we can see here, there is no rhyme or reason to the two sets of scores. Some people who have low physical fitness enjoy reading and some don't, while some people with high physical fitness also enjoy reading and others don't. The fairly flat line indicates that there is no relationship between these variables. Pearson's R, the statistic most commonly used for this type of design, is called a correlation coefficient. Correlation coefficients range from -1 to +1. A correlation of 0 indicates no relationship. Correlation coefficients between 0.10 and 0.29 represent a small relationship. Correlation coefficients between 0.30 and 0.49 represent a medium relationship. And correlation coefficients equal to or greater than 0.50 represent a large relationship. The sign, positive or negative, indicates whether the relationship is positive or negative. Fortunately, we can use a spreadsheet such as Excel or an online calculator to calculate the value of R. The size of the correlation coefficient can help us determine whether the relationship is meaningful or not. As a rule of thumb, medium or large size correlations may be more meaningful. However, smaller correlations may also be meaningful, depending on the context. For example, a small correlation between a variable we can influence, for example, vocabulary level, and a variable that is high stakes, for example, licensure exam score, may be worth paying attention to, even though it is small. It may be worthwhile to try to strengthen test takers' vocabulary level prior to their taking the licensure exam, as a boost in vocabulary may mean the difference between passing or failing the exam. We must ultimately decide whether a correlation is meaningful for our setting and our participants. As we have been discussing correlational designs, we have been talking about variables that have an inherent numeric value and that can be measured. However, some variables are categories and are not measured with numeric data. Examples include gender, ethnic group, pass-fail status, and diagnosis. These variables cannot be correlated using R. Frequencies and percentages can be compared instead. For example, the percentage of boys who passed a course versus the percentage of girls who passed a course. Large discrepancies suggest that one variable, for example, passing a course, is related to one status on another variable, for example, gender. The next research question we might ask is there a difference between groups? In a two-group comparison design, two groups differ on some variable. Both groups are analyzed with the same outcome measure. For example, does Class A differ from Class B in terms of their achievement? Does the treatment group differ from the control group in terms of stress level? Do new teachers differ from experienced teachers in terms of the time they spend grading homework? In each case, we want to know whether there is a meaningful difference between the two groups' outcomes. To use this design, there are several steps. Step 1. Measure each participant on the outcome variable. Step 2. Determine each group's mean for the outcome variable, excluding any outliers. Step 3. Determine whether the group means are different. In most cases, the group means will be different from each other to some degree. The question is whether the difference is meaningful. This will depend on the context, the participants, and the measure used. Let's look at an example, class differences in achievement. Two classes are tested with a standardized achievement test with possible scores ranging from 55 to 145. Scores of 85 to 115 are considered average. Class A has a mean score of 100. Class B has a mean score of 105. The two classes' means are literally different, that is, 5-point difference, but they both fall within the average range. We would likely conclude that the classes did not differ in terms of achievement, as the difference of 5 points is not really meaningful in this context. Here is another example, stress levels and treatment condition. Two groups take a standardized test measuring stress, with possible scores ranging from 0 to 10. Scores of 0 to 2 are considered typical. 7 and above are considered high. The treatment group, who receives some sort of intervention to decrease stress, has a mean stress score of 2. The control group, who did not receive the special intervention, has a mean stress score of 7. As in the previous example, the two groups' means differ by 5 points. However, here, a 5-point difference is large. One mean is considered typical while the other is high. We would likely conclude that the groups differed in terms of stress level, with the treatment group doing better than the control group. Now let's look at a third example, grading and level of experience. New and experienced teachers track the amount of time they spend each week grading homework in minutes. The new teachers report a mean of 300 minutes. The control group has a mean of 150 minutes. In this example, there are no external standards provided to determine what constitutes a typical amount of time. However, the new teachers report spending twice the amount of time on grading that the experienced teachers spend. Given this large discrepancy, we would likely conclude that this is a meaningful difference. New teachers are spending much more time on grading than experienced teachers spend. The key here is that we must determine our standards for deciding whether the difference between group means is meaningful. Published tests often contain guidelines for this. However, decisions about other measures will depend on the circumstances. A 1-point difference between groups may be meaningless in the context of a test with a wide range of possible scores. A 1-point difference may be meaningful if it represents the difference between passing and failing a test, however. The third type of design is a one-group pre-test, post-test design. This is meant to answer the question, is there change over time? One group is measured with a pre-test. An intervention is provided. The group is measured again with a post-test. For example, we might look at whether students who participate in small guided reading groups, an intervention, experience a change in reading comprehension, outcome. We might also explore whether people who participate in social skills training, intervention, experience a change in social skills, outcome. In both cases, we want to know whether the group experienced a meaningful amount of change over time. Here are the steps for the one-group pre-test, post-test design. Step 1. Measure each participant with a pre-test. Step 2. Determine the group's mean on the pre-test. Step 3. Deliver an intervention. Step 4. Measure each participant with a post-test. But note that the pre-test and the post-test must be equivalent. Step 5. Determine the group's mean on the post-test. Step 6. Determine whether the group's post-test mean represents a meaningful change from the group's pre-test mean. Change may involve an increase or a decrease. Meaningfulness will depend on the context, the participants, and the measure used. Let's look at a couple of examples. First, change in reading comprehension. A group of low-performing readers in a 5th grade class take a reading comprehension pre-test and achieves a mean score of 10. Possible scores 0 to 50. The group receives an intervention targeting their reading skills, small guided reading groups. After a few weeks, the group takes an equivalent reading comprehension post-test and achieves a mean score of 30. We must determine whether this 20-point increase is meaningful. To determine meaningfulness, we must establish a standard. In other words, what does the size of the improvement actually mean? Be careful of just using percentage increase. Does an increase of 300% on the scale actually mean 300% better reading comprehension? For a scale like this, probably not. What ability level does each score represent? Suppose the scale instructions indicated that a score of 10 is characteristic of low performance, while a score of 30 represents approaching grade level performance. In this case, the improvement would be meaningful. The group would have moved, on average, from low reading performance to approaching grade level performance. Here is another example. Adolescents with autism spectrum disorder are rated on their social skills, pre-test. They engage in a mean of 2 socially appropriate behaviors per day. The adolescents participate in individual skills training sessions. The adolescents are rated on their social skills again, post-test. Now they engage in a mean of 4 socially appropriate behaviors per day. Once again, we must determine whether this increase is meaningful. To determine meaningfulness, we must again establish a standard. In this case, we can say something about the relative frequency of behaviors before and after the intervention. The post-test mean, 4 behaviors, is twice as large as the pre-test mean, 2 behaviors, representing a substantial improvement. Although 4 behaviors is still a relatively low number, it may represent important improvement for behaviors that are difficult to change. So far, we've only been talking about relationships, differences, and changes. We have not addressed the issue of what causes the relationship, difference, or change. In all 3 designs, it is important not to draw firm conclusions about the cause of any relationship, difference, or change observed. In a correlational design, variable A may cause variable B, variable B may cause variable A, or some other variable may cause both variables A and B. In a two-group comparison design, a difference in outcome may be caused by the variable of interest or by some other variable not measured. Furthermore, in a one-group pretest post-test, a change may be caused by the intervention or by other factors, such as natural improvement over time. Therefore, we must stick closely to the research question when drawing conclusions. We should say that a relationship was or was not present, that a difference was or was not observed, or that a change did or did not occur. To summarize, there are three main research questions, each of which has a corresponding design. Is there a relationship? Use correlation. Is there a difference between groups? Compare means for two groups. Is there a change over time? Compare pretest and post-test means for one group. The answers to these questions depend on the standards we set for determining whether a finding is meaningful. Standards are influenced by context, participants, and measures. Finally, caution should be used when interpreting the cause of any results.